Welcome back. Welcome back. We are on lesson 4 and topic 1, amazing ones. We're on page 387. And what we're doing is here, we're trying to make sure to verify equivalent expressions. Very easy lesson, be quite honest with you. It's not too bad at all. It's pretty short too. But y'all are smart as heck, so you'll figure it out too. So we're going to start with this information here. Determine which pairs of ratios are equivalent. Explain how you know. Explain, which means you need to write sentences, show your work. That's going to be told. So 5, 7, and 100 and 140. To determine if these two fractions are equivalent, you just simplify. There's really nothing else. I could divide this by 20. And honestly, that would give me 5/7. They're absolutely equal. That's absolutely true. All you do is simplify the fractions and see if they're the same. There's nothing else to it. Very straightforward. 105 over 100. Does that equal, I wrote true. Does that equal 20 over 21? I could tell looking at that it's gonna be false. That's me though. Notice I didn't explain any of these. I better explain before y'all snap at me. So what's here? I divide each by 5. And that actually gives me 21 over 20, which is not the same, so false. So I should write this as sentences, my explanation. I don't know why I didn't, because I'm a little cuckoo for Cocoa Puffs. Oh, green. Green's nice. All right, so for this one, 5/7 does not equal 100 over 140. Oh, it does. It does. Oops, I suck. What's wrong with me? Computer, stop acting weird. It doesn't want to erase y'all. I don't know why. Okay, here we go. 5/7 does equal 106, does equal 100. I am out of it today. 100 over 140 because if simplified, oh, yeah, simplified. That's a horrible explanation, but whatever. If you divide each by 20, you get 5/7. For the next one, I divided 105 over 100 by 5 on numerator and denominator with solution with 21 over 20 with solution being 21 over 20 and 21 over 20. Oh crap, my computer's being weird. Does not equal 20 over 21. You're going to do number 2 and 4, explain to the best of your ability. That's all I need from y'all, which we've done sort of this in class already before, so it's nothing too out there. So here we go. We're gonna go on to page 389. We're skipping 388. That's a dumb page. Sorry, I don't like it. I ain't gonna lie to you. All right, we already know what equivalent expressions are. They're expressions that are absolutely equal. It doesn't have to be 2, it could be 3 or 4, but we're gonna do 2 in this class. So we have two potential equivalent expressions here, and we're trying to determine if they're equal. If two expressions are equal, then they are either exactly the same question and they're written differently, which you could simplify the expressions and determine that. They also have the same, if they have the same inputs, they have the same outputs. So if two expressions are equal, then for every x, or rather every input, no, I'm going to say that differently. Then, I should say that in words. Then for every independent variable, should match with corresponding equivalent output. Oh, dependent. variable. In layman's terms, because I'm not going to make you say it like this, these numbers should match all day. That's the layman's terms. The outputs or dependent variables should match all day when they have the same inputs uh, placed using substitution, substitute into each expression. So this is the first expression. This is the second expression. If I input 0, these two values should match. If I input 1, these two values should match. If I input 2, these two values should match. If I input 3, these two values should match. So we have to do each one trial and error like. So when x is equal to 0, then for the first one, I get 2 times the sum plus 3, 0. If I get that math, I'll get 4. And if I do the next one, the second, 5 times 0 plus 4, I get 4. So they're matching so far. Yay. They have to match all the time and never stop. If x is equal to 1, for the first one, I'll get 2 times 1 plus 2 plus 3 times 1, and I'll get 9. Interestingly enough, for the second one, I'll also get 9. For the third one, if I input 2, I will get 14. And I will also get 14 for the next one. And the last one, I will clearly get 19. You are going to show your work for that one on the side. I will not show the work for that one. You're going to show that one. For letter A, what can you determine based on the set of values in the table? It's very evident the two equations are equal. Because every dependent variable or output, I use say output, are equal for the same input. What do you need to know to verify that two expressions are equivalent? That every time you substitute in a value or independent variable, the outputs are equal, which we already stated in the beginning, so I'm not going to do that. That's all the way over yonder. And that's perfectly fine. You don't have to repeat right there. That'd be dumb. Okay, we're going to move on to page 390. If you need to take a minute to pause it, then please do so. So for this one, they already did the table and we got everything matching. Haha, do your work. Aha, gotcha. So we already know what's the input. This column here is the input. These two are dependents. There's two different ones. It's also known as outputs. This is also known as independent. So for these problems, it's pretty straightforward. We're just going to plot them and we're going to see it geometrically if they are actually the same. So we're going to plot them. So I'm going to plot 0, 4. I'm going to plot, I'm going to plot this first one in red. Sorry, let me say I plot this one in red and the other one's going to be greeny, 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 greeny. It would not change, sorry. Okay, so the next one is 114, right? No, 19. Oops, I can't count, yo. What's wrong with me? 19, and then we get 214, and then we get 319. Ooh. Now I'll use green. Notice they're the same points. I'm going to circle it like this to show they're equivalent, because if you put it in the same spot, you can't tell. Looks like each one lies on top of each other. We call this a collinear graph. Collinear means they lie on top of each other. How does the graph demonstrate that the two expressions are equivalent? It's collinear. The points are the same. And lie, I'm not sure if it's L-Y-E or L-I-E. I don't know. I suck at the word. I want to look it up real quick. No, hey, this math class ain't English. Don't be judging me, lie. Students. I can't even say words. What is wrong with me? I'm insane. Like, I think it's LIE, right? Yeah, it's a lot. Like, what's wrong with me? I mean, this is a drug or something. Okay, fixed it. Haha. I had a brain fart moment. Collinear, the points are the same, are on the same line. Oh, wait, we're not on line. They're the same. I can't even talk. Yeah, you haven't done linear functions yet. Y'all don't even know what the heck a function is. It's okay. We'll learn what a function is when you're in seventh grade, I think. You'll talk about functions. All right, number three. We're going to rewrite the given expressions and identify the property. So we have to remember some old properties, and we're going to recover that again in class. So here is the D property, because we have a parentheses, a sum or difference being multiplied by a value. This is known as the distributive property. Distributive property. So 2 times x is 2x, 2 times 2 is 4. And then we combine like terms or addition, you should get 5x plus 4. Nothing hard. We've done this before. No biggie. So for the next one, are the two expressions equivalent? So they're asking you specifically, is this expression equal to this expression? So is 2x plus 2 plus 3x equal to 5x plus 4? And explain your reasoning. It's absolutely evident they're the same. What did all I do was simplify this expression. This is just written in simplified form. Yes, they are equal. We just simplified the expression. Very straightforward. So we're going to go to page 391. Consider these two expressions, which we already know how to do. So I'm leaving number 5 to your device. You're going to do that for me. Show your work. You know I'm going to look for it. Use the table to sketch the graph, both expressions on the coordinate plane. What does graph tell you? I actually want you to do that one. Yes. They said use a square to represent and a triangle. You don't have to do that. You can just do a circle for one and then an open circle on the other, whichever you want. If you want to use a triangle, that's perfectly fine. Just make sure you can differentiate between which is which, because I'm going to ask you that on the test. I'm in that test review. What does the graph tell you? You're going to do that for me. Number 7, it says use the distributive property to rewrite this expression. Obviously, that's 2x plus 10. We're just multiplying, which we did. Be happy I did it for you. Unless I make you do extra work. Say thank you. Okay. Are the two expressions equivalent? Explain your reasoning. So you have to explain that. I'm not going to answer. Oh, wait. Which one is they asking for? Did I just lose my brain? Oh, no, I didn't. Okay, yeah. You're going to answer number 8 for me. You're going to tell me is from, I'm sorry, from, oh, stupid computer. Work. Why don't you work? This is when I want some candy, y'all. I want Gushers or something. Candy sounds great right now. Ooh, chocolate. Chocolate sounds great. Hershey bar with some ice cream. Yeah, that's good. They're asking, are these two expressions equal? Sorry about that. My computer is acting like stupid. Work, computer. Stop being dumb. You guys, it won't work for me. It's not working. Okay, it's working. Haha. There we go. It's working now. Ah, I win. Oh, my pen. Okay, nothing. I'm having a day, y'all. It's a day. It's a day. So they're asking you if 2x plus 5 is that equal to 2x plus 5. I want you to tell me that given your information from letter B in your graph. You're going to tell me that. So I'll be looking for that next class. That's what I want to do. So I'm going to move on to page 391. If you need a pause to do it, then please do so. Number 9 says use the table and properties and graph to determine. Yeah, that's a lot of work. We already did this. That's stupid. We don't need to do that again. Okay, this is bonus. Bonus. First 5 people show me the work, and I may give you a Brewster buck, but I'll definitely give you some bonus from my class. If you're a Tiger team, since I'm cheater right now, I'll probably give you some Starburst or candy or something. You have to explain it though, and then tell me in the hallway. You know the drill. All right, I give you a shot. You got a shot. I'll make that bonus since we sort of already did this before. All right, like to see it. So we're gonna move on to page 393. First five people, I'll give in Brewster Bucks or Starburst. I haven't decided. One of the two. You have to explain it to me. Show me you're super duper smart because I know you're smart. And the last one, page 393. Identify the property. It says identify property or operation used to rewrite each expression. So you're looking for what did they do from the given, which is what they gave you, to the next step. I noticed they multiplied these two. That's all they did. They rewrote that with commutative property. Why is my pen not working? Work, pen, work. Y'all, I'm having technical difficulties, please. Oh, it's working now. Okay. Commutative property of multiplication. And then how did the next step go? They multiplied, simplified it, got it. How do they go from here to here? They clearly did distributive. Oh, work, you stupid computer. So that's all you're trying to tell me. And then the very last step, they just simplified. That's all they did. That's all you're stating to me. You're going to do that for number 2 and 3. I'll be checking that out. Like I said, I don't care if you're wrong. I want to see what you're thinking so I have an idea how to help you in class. All right, but that concludes the fourth lesson, Magic students. I look forward to seeing your amazingness tomorrow or the following day, or whatever day it comes by next day. I don't know. Remember, if you want some Starburst or Brewster Buck Sheet, you know what to do. Give me that bonus. All right. I want to see that bonus paper if you want to get that though. But good job, y'all. Look forward to seeing you tomorrow, the next day. I don't know what day right now. Today I'm having a weird day, but it's okay. All right. See you later, y'all.